Billahi minash shaitani rajim. Bismillahir Rahmanir Rahim. How are you, students? I am your teacher Aftab Alam, and I will teach you physics. Today we will study unit number 4, lecture number 24. Today topic is resolution of forces. Resolution of forces. So first I will define it, then we will go into detail, and then we will derive relation per different components of during resolution of forces. The definition written is splitting up of the force into two mutually perpendicular components is called resolution of forces. So it is written mutually two components. The splitting up of a single vector, a single vector into two perpendicular components. For example, this is a vector. I will change the color of the pen. The splitting up of a single vector into two perpendicular components is called resolution of forces. So this is the component of force. This is force. From this point you will draw perpendicular on x-axis. So this will be the horizontal component, and from this point you will draw perpendicular on y-axis. This will be the vertical component. So here we have splitted a vector into two components. For example, this is written here. You will put arrow over it. This is the horizontal component and this is the vertical component. So the splitting up of a single vector into two perpendicular vector is called resolution of forces. So now this is the force to this point. Here we draw perpendicular. This will give the horizontal component, and if you draw perpendicular on y-axis, this will give the vertical component. So F is equal to Fx plus Fy. These are the component of forces. Now resolution of forces in detail. Resolution of forces. A force implies breaking a force in the component such that the component combined together will have the same effect as the original. For example, F is equal to Fx plus Fy. This is the vertical component, this is the horizontal component. So here a force is given. It makes an angle theta with the horizontal axis. This is force, this is F1 and this is F2. So this is in term of Fx and Fy. This is written Fy, this is written Fx. This is x-axis, this is y-axis. They have taken the things in a different here there is we take vertical axis along along this direction and horizontal axis along this direction. So there is a I will explain it later. It is here we have to take Fx and here we have to take Fy. The force if acting at an angle theta can be resolved into the forces F1 and F2. The component Fx, F1 represents the y component and F2 represents the horizontal component. And these components must be perpendicular to each other. For example, this is a vector. This is y-axis and this is x-axis. This is Fx and this is Fy. So one component is along in this direction and the other component is in this direction, so they are mutually perpendicular. The angle is 90. Now component of forces. Resolve each force into rectangular components. Determine the component of the resultant by adding the corresponding force components. Calculate the magnitude and direction of the resultant. So I will explain further components of forces. Now This is F vector. Whatever the direction is, does not matter. This is the y component and this is the horizontal component. If you draw parallel line to this vector, it will give you the resultant vector. Resultant vector will be always the sum of its horizontal component plus sum of its vertical component. Magnitude will be equal to rx square horizontal component, vertical component, and square root. So going to next. So I will explain the torque later. First I will do some derivation for you people. Now I have enlarged the screen. So first we have two components. This is x-axis, this is y-axis. This is force. Draw perpendicular on x-axis, this will give you the x component. Draw perpendicular on y-axis, this will give you the vertical component. So just write f in vectorial form is equal to fx vector plus fy vector. In vectorial form, it should be written like this. Now, according to Pythagoras theorem, if it is O, it is A and this is B. The hypotenuse, which is OA whole square, will be equal to OB whole square plus OBA whole square. We have written this by Pythagoras theorem. So OA is equal to f square is equal to fx square plus fy square. Now take this equation again, and f is equal to fx square plus fy square. Take the square root. Take the square root. Now if you put the square root, you will get f is equal to fx square plus fy square square root. So this will give you the resultant vector. Now we have derived that f is equal to fx square plus fy square square root. Now cos theta is equal to perpendicular by base by hypotenuse. So here we will write cos theta is equal to base is fx and hypotenuse is f. So from this we can write fx is equal to, by cross product, f is equal to f cos theta. This is the horizontal component. This is the horizontal component. So from this we can define the horizontal component is the component of force, the horizontal component. The component of force which is acting along x-axis. So fx is the horizontal component and it is equal to f cos theta. Vertical component. Vertical component. Vertical component. The component of force which is acting along component of force which is acting along y-axis. The component of force which is acting along y-axis is called vertical component. So now I will derive sin theta is equal to perpendicular by hypotenuse. So sine theta is equal to fy divided by f. So fy is equal to f sine theta. Now fy is equal to f sine theta. So these are the this is the vertical component. Now parangle, tangent theta will be equal to perpendicular by base. So tangent theta is equal to fy divided by fx. Theta is equal to tangent inverse fy divided by fx. Fy divided by fx. Now the summary: resolution of forces is the splitting up of a single vector into its component. The splitting the splitting up of a single vector into its component. F resultant vector, which is f in this case, will be equal to fx square plus fy square root. Theta will be equal to tangent inverse fy divided by fx. Fx is equal to horizontal component is equal to f cos theta. Vertical component is equal to fy is equal to f sine theta. F sine theta. So in here we have first we define the resolution of forces, the splitting up of a single vector into its component. Here a vector is given, here we obtain the horizontal component, and here we obtain the vertical component. Then we resolve the vector into its rectangular components. For example, if you this is a vector, this is the horizontal component and this is the vertical component, the angle between these two is 90. So if angle is 90, they are called mutually perpendicular components. Mutually perpendicular components. Mutually perpendicular components. If two components of a vector makes an angle of 90 degree with each other, then these are called the rectangular components of a vector. Now I will explain torque. Now torque is the rotational effect of a body. The rotational effect produced in a body is called torque. The rotational effect produced in a body is called torque. The rotational effect produced in a body is called torque. The rotational effect produced in a body is called torque. Here torque is measure of the force that can cause an object to rotate about an axis, just as force is what causes an object to accelerate in linear kinematics. Torque is what causes an object to acquire angular acceleration. Torque is a vector quantity. The SI unit of torque is Newton meter. Torque is the cross product of force and momentum. This is moment arm. This is force. So torque is the rotational effect produced in a body, and torque is a vector quantity. And next is unit. Torque is equal to R cross F. So unit of force is Newton and moment arm is meter. So Newton meter is the unit of force. Now if this is a point about which rotation take place, so force is acting at this point, and from this point this rotates. So the distance between point of rotation point of rotation, and point of action of force is moment arm. So the distance between fulcrum, point of rotation, and point of action of force, is called torque. Now calculating torque. This is symbolic representation of torque. This is moment arm. This is force. Moment arm. This is point of action of force. This is point of rotation. This distance is called moment arm. Now you can see, if you can see, in this direction, torque is in the upward direction. When it moving in this direction, this is direction of torque. Reverse is the direction. The torque reverses the direction. Here it reverses, torque is downward. So torque, the direction of torque can be found out by right hand rule. Right hand rule. Curves the finger in the direction of rotation. The thumb will give you the direction of torque. This is the rotational direction. Now this is the rotational direction. So keep your fingers in the direction of rotation. The thumb will give the direction of torque. Now you studied that torque is the rotational effect produced in. Now if you can see, this is center point about which rotation take. Body is rotating in this direction. This is moment arm and this is point of action. Here this is the direction of force. This is the moment arm. Now this is the moment arm. This is force. This is the direction of torque. Keep the finger in the direction of rotation. The thumb will give you the direction of torque. Now moment arm is in this direction. Force is in this direction. This is the direction of force. The torque will be in the upward direction. Keep this finger in the direction of rotation. The thumb will give you the direction of torque. This is the direction of torque. Keep the fingers in the direction of rotation. The thumb will give you the direction of torque. Now difference between torque and moment arm. Difference between torque and moment arm. Torque is what? Torque is a moment force. Torque is often presented as Newton meter. Reveal tends to be used when there is an axle or pivot to be turned around. This is pivot. Here the force is applied with this one. Spanner. Moment is a static force. Moment is typically presented as Newton meter. Tends to be used essentially non-rotational situations such as analysis of force on a beam. So moment is a static force, is in static situation. Now keep the fingers in the direction of rotation. The thumb will give the direction of torque. The right hand rule can be used to determine the direction of a vector. Torque is a vector. Curves the finger in the direction of the loop. Your thumb will give the direction of torque. Now line of action of force. This is the line along which F3 is acting. So this line is called line of action of force of F3. F2 is acting in this direction. This one. This is called line of action of force F2. This is F1. This is a line along which F1 is acting. This is direction of line of action of force of F1. So line of action of force is the line along which the force is acting. Here the Penger's rules is again explained. Here force is in this direction. This is the point of rotation. The torque will be in the upward direction. Now here if you can see the spanner, this is point of action of force, and this is the fulcrum, point of rotation. So keep the fingers in the direction of rotation. The thumb will give the direction of torque. Now here torque is a tendency to rotate It is also called the moment. The magnitude of moment is proportional to the magnitude of the force and the perpendicular moment arm. Now we will explain further. Moment of force torque. The rotational analog of force is said to be torque. Force means, if you convert force into rotational analogy, it means torque. Torque is a single particle. The moment of the force acting on the particle with respect to the origin O is defined as, this is formula. Now this diagram is not in your course, so leave it. Now we first define the torque, that the rotational effect of a body is called torque. Then we write formula, torque is equal to R cross F. Then we write the unit. So now I will explain types of torque. There are two types of torque: clockwise torque, anti-clockwise torque. Anti-clockwise torque. If the anti-clockwise moment and clockwise moment are equal, then the saw is balanced. If this torque and this torque is equal, it is called, the body is said to be balanced. This will not rotate. When something is balanced about a pivot, total clockwise torque is equal to anti-clockwise torque. So I will explain, and the explanation is that we have two types of torque. Now this is clockwise torque, and this is anti-clockwise torque. So the direction of this torque is upward. Clockwise torque have direction downward. So clockwise torque is negative. You will take its value negative, because it rotate according to right hand rule. Its direction is downward, so it will be taken negative, and anti-clockwise direction is upward, so it should be taken positive. So according to right hand rule, clockwise torque will be taken negative. Anti-clockwise torque will be considered positive. So when clockwise torque is equal to anti-clockwise torque, then the body will be balanced, and it is called, so clockwise torque is equal to anti-clockwise torque. This is principle of moment or principle of rotation, also called second condition of equilibrium. So the body is said to be balanced if clockwise torque or clockwise moment is equal to anti-clockwise moment. Thank you, students. Wish you best of luck. Allah Hafiz.